Hi girls, so we're here today to talk about logarithms, and I first thought I would show you what the curve looks like, because we haven't really done that yet. So we start here with just the exponential. Now if you remember when we first defined these things, we said that if y equals e to the x, then x must equal log base e of y, okay? And one way to think about it in terms of graphing, now you don't actually need to worry about necessarily understanding why the graphing works, but it's the opposite. Like y equals e to the x and x equals log y, they are inverses, which means they do the opposite. And what that means is it means that when you're drawing them, you can kind of switch the x and y coordinates. So first thing I'll do is add the line y equals x on there, and what we're going to do when we sketch log is we're going to think of that as basically a mirror. So if I think of the blue line as a mirror for the red line, then I end up with the green curve, which is the log curve, and I'll hand draw one. Don't know why, because it's not going to look anywhere near as nice, but let's just pretend there's my x and y axis. Then my log curve looks like an exponential, except it's got a vertical asymptote as the y-axis. It passes through x equals 1 when y equals 0, and it's got the same kind of shape as the exponential curve. I want you to notice, how far below the log curve is to the exponential, to the line y equals x. Like, look how far below this thing is. It gets even lower. So what we could also do then is we could sketch a bunch of different ones. So, for example, we could sketch y equals log base e of x, all in brackets, minus 1. So that would be the same curve. If there's the original, here's the new one, shifted down 1 unit. And there should be a quiz question popping up now for you to find the x value here. Okay. And now I'll show you how to find it. So you set y equals 0. So you get log e of x minus 1 is 0. So log base e of x is 1, which means that x must be e, because log base e of e is 1. Okay. And then we could do other types of shifting, like we could do y equals, log base e of x minus 1. So that would be the log curve shifted to the right 1 unit. So there's my new asymptote at 1. And again, there'll be another quiz question to check what x is. And hopefully it's fairly obvious that it's 2. Right, we shifted to the right 2 units. That's sketching basically done. Now let's talk about derivatives. And I'm just going to start by writing down the rule. And I can't remember, I feel like I might have used blue pen the other day. But so if y equals log base e of x, then the derivative is 1 on x. And that's something that we can prove. There's proof in the textbook on page 333, it looks like. But you don't need to worry about being able to do that necessarily. Okay, so I'm going to do an example for you, and then I'll give you a quiz question. So the first thing, obviously we need to think about things like the chain rule. So let's say that y equals log base e of 2x. Okay, so what's dy dx? So I use the chain rule. Right? So here's the inside function. So I do 1 on that whole inside function, because that's what log is, remember? When we differentiate log, we just take whatever we're taking the log of, and we put it on the denominator. And then we times by the derivative of the 2x, right? So we times by 2. And this gives us 1 on x. That's a bit odd. The reason that that works is that y equals log 2x, if you use log laws, is the same as y equals log of 2 plus log of x. The derivative of log 2 is 0, and the derivative of log x is 1 on x. So the derivative is 0 plus 1 on x. Wow! Isn't that exciting? Let's do one or two more together. So what about if I have y equals log of x squared minus 3x plus 2. So, derivative. Right, I take the whole thing on the brackets and I put it on the bottom. And then I multiply by the derivative of the thing that I just put on the bottom. Finished. Okay. We could try factorising and things. So what will that be? 2x minus 3 over x minus 2, x minus 1, but you can't cancel anything out or anything like that. So that's a chain rule. Let's just do one more. Let's do a product rule maybe. So let's do y equals x log x. And obviously we'll have to combine all these things and stuff. So let's call this one here P and this one here E. Sorry, I should pick my letters of favourite students. I'll try and remember that for next time. So there's my P. Okay. And then the product rule is, well done, inside plus outside. I just assume you get everything correct. So then the derivative is x times 1 on x plus 1 times log of x. So that's 1 plus log of x. So pretty. And there's Winterbottom to say goodbye. Come to class ready to do some work on Tuesday. See you then.